Hello, today we'll be discussing about this geotechnical engineering part 1 introduction. Here we will be discussing about definitions, brief history, scope and limitations. We all know geo means earth and technological means spatial knowledge. First of all, let us discuss about what is soil. We all know in geotechnical engineering soil plays a major role. So soil is derived from a Latin word soilium, which means the upper layer of earth that may be dug or plowed, specifically the loose surface material of earth in which the plants are grown. First of all, Dr. Carl Terzaghi has termed soil mechanics in his book Erdboa Mechanics in 1925, which was published in German language. Soil mechanics is the application of law of mechanics and hydrology to engineering problem dealing with sediment and other unconsolidated accumulation of solid particles. It deals with the site investigation, design, construction of foundation, earth retaining structures, earth structures, etc. We all know what is geotechnical engineering. It is a broader term which includes soil engineering, rock mechanics and geology. Rock mechanics means dealing with the mechanics of rocks. Foundation engineering. It is a branch of civil engineering which is associated with design, construction and maintenance and renovation of foundation, footing, wall, piles, caisson and all other structure members. If you talk about the history of the soil in the past primitive ages, we all know soil is being used for building a earthen house, road, for transportations. Even dams, earthen dams were also constructed during that period. Even you can see the drainage of Indus Valley civilization, which was a good example as a history. Let us talk about some of the laws of mechanics and hydrologics. Here are some of the scientists, researchers has given some of the theories related to this soil mechanics. Coulomb has given the theory of earth pressure. Darcy's law has given the law of permeability and seepage. Rankine has given earth pressure theory. Morse has given stress circle method. Proctor has given compaction theory. Terzaghi has given theory of compaction or consolidation even. Casagrande has given classification of soil, seepage and consolidation. Meyerhoff has given theory of bearing capacity, shallow and deep foundation. Now let us talk about the scope of geotechnical engineering. Here you can see some of the scopes where geotechnical engineers are working day and night. First of all, if you talk about any structure, foundation comes in picture. Thereafter, retaining structure, stability of slope, underground structure, pavement design and earthen dams. When you talk about foundation, there are different type of foundations used in the structures, which may be mainly classified into two categories, shallow and deep. In shallow, there are isolated footing, step footing, slope footing, combined footing, even draft foundation. In deep footing, we will be talking about piles, caisson, coffer dam, well, foundation, etc. You can see some of the pictures of shallow and deep foundations. Retaining structure. Even retaining structures are used in the bridges near the water bodies such as dam, canal, etc. So you can see some of the reservoirs where retaining wall is used, bridges, even tunnels where retaining wall is being used, boundaries wall where retaining wall is used. Stability of slope is also much more important in soil mechanics. If the soil surface is not horizontal, there is a component of weight of soil which tend to move it down. Thus, the stability of soil is important. In tunnel also, design and construction of underground structures. These tunnels plays a major role in the roadways and railways. Pavement designs. In road construction, different layers of road and its stability is much more important. So design of pavement, earthen dam. Ukai Dam is the best example for earthen dam, which is a huge structure in which the soil is used as a construction material, generally to store the water. Water reservoirs are being constructed. Here are some of the limitations. If you see, the strength and behavior of soil mainly depend upon pressure, drainage, environment, and many other factors. Type of soils changes with the different location and even place to place and depth to depth. Most of the soil is underground and cannot be inspected. This is also a major challenging role. Properties of soil also changes in the varying depth of soil. Linear and unique stress strain relationship, that solution of theory of elasticity cannot be directly applied. Soil are very sensitive to disturbance, so it is very tough to interpret the results. These all are some of the limitations of soil. Thank you very much for listening. Thank you all.